My pleasure to introduce our next speaker. Brenda Dunne holds degrees in psychology and the humanities from Mundelein College and an MS in human development from the University of Chicago. She was manager of the Princeton Engineering Anomalies Research Laboratory and has been working at the forefront of consciousness studies for a very long time. We are honored that she has chosen to carve out time in her busy life to join us. Would you please welcome with me Ms. Brenda Dunne.
Good evening. Delighted to be here. It is an honor to be part of this conference, which I believe is addressing one of the most important questions that we as humans can address: the balance between our analytical, scientific side and our metaphysical, emotional, experiential side. The study that I'm going to discuss briefly tonight and a little bit more extensively tomorrow is one that we used to refer to as the marriage of the white coat and the white turban. I have to introduce myself. I was the white turban. My colleague, Robert John, who passed away a year ago, was the white coat. He was the one who established the Princeton Engineering Anomalies Research Laboratory, or PAIR Lab, in the university, in Princeton University School of Engineering back in 1979. His interest in the topic really was quite far from his traditional or canonical academic interest, which was advanced aerospace propulsion systems. But for his sins, he served as Dean of the School of Engineering for some 15 years. And in that context, he had an opportunity to supervise an undergraduate independent project. This student was interested in exploring whether human consciousness could influence random physical systems. She had gone to a number of her faculty members who said, we don't know anything. No, go do it in something a little bit more appropriate. But she recalled that when she had entered the university as a freshman, Dean John had welcomed them by pointing out that if they did well in their studies, when they got to be upperclassmen, they could do their independent work on any topic of their choosing, and she was calling him on it. So he gave this a bit of thought, and I'll make a long story short, but basically he came to the conclusion that whether or not there was anything to the anomalous phenomena, he thought that the design and construction of a random event generator was a perfectly legitimate project for an engineering undergraduate to undertake. So he agreed to supervise it. And by the time the student finished her project a couple of years later, and frankly lost interest in the topic, it left him scratching his head and saying, what do I do with this? If this is for real, if the results that she produced are for real, then engineers ought to be studying it. This has important engineering implications. So he went around about establishing the program with some, more than some resistance from his university administration, and with the financial support of an aerospace colleague of his, Mr. James McDonnell, who offered to fund the program. And for whatever reason, our paths crossed, and he invited me to come and work with him as his laboratory manager. And in the spring of, or I guess the summer of 1979, I went to Princeton, and we proceeded to set up the program. The PAIR program basically had three components. One of them was a body of experiments in human-machine interaction, whereby the question was whether human intention or human consciousness could actually affect the behavior of random physical systems or processes. This was basically extension of the student project. The second part of the program was a series of experiments in what we called remote perception. Other people know it more popularly as remote viewing, where people claim to acquire information about distance, locations. And there our purpose was to see if we could develop some quantitative methods whereby we could actually measure an amount of information that was being acquired in this process. And the third part of the program was the part of the program that was, what is going on here? Basically, can you develop some kind of theoretical model that can accommodate experimental evidence that was coming out of these research efforts? Now, the program actually started off as a very pragmatic one, namely to see whether modern engineering technology was susceptible to anomalous influences associated with the consciousness of their human operators. Our focus was on the machines, not on the operators, not on the humans. And over the ensuing 28 years, we generated, or our experimental participants generated, several millions of trials in both of these categories that gave us some very interesting and suggestive insights into what might be going on. One of the, that's a longer story, but one of the important things that we noticed was that when we talked to our participants about how their experiences, they almost inevitably said, you know, it's more than me just having an intention. I have to have some kind of a resonance or a sense of emotional connection with the process or with the machine. If I'm not emotionally involved, it doesn't seem to work. So there's more to it than just the intellectual side. Another part that was rather interesting was we found that if we took our random event generators into larger venues where there were many people, large groups of people who were involved in some sort of emotionally shared experience, maybe a concert, maybe a play, maybe a religious service, and we just had the random event generators running, we were seeing results that were really quite strong, in many cases much stronger than what we were seeing in the laboratory. But perhaps the most intriguing and puzzling aspect of these experiments was their non-locality. Namely, we found that the experimental machines could produce the results, the effects we were seeing, even when the human operators were up to thousands of miles away. Not only did distance not matter, time didn't matter. People could generate their intentions up to several days or even weeks before or after the machines were run. Didn't make any difference. This non-local phenomenon really raised important challenges to the scientific interpretation of what was going on here. It was very clear that there was no physical, no psychological model that could accommodate the effects of this type. The only thing that possibly could be associated with it was in a metaphorical sense, when you ask where else do you possibly see situations where a very tiny effect can compound over many millions of events, many millions of trials to produce a shift in a distribution mean. How about evolution? Are we looking at something that might be what used to be called the elan vital, the life force? And where does consciousness come into it? Because clearly the non-local results indicate that what we were seeing were not effects that were being generated by the physical brain of the human operator sitting in front of the machine. So anyway, I think I'm out of time, so I will leave it at that and leave you with the question of, the question of this conference. what is consciousness? Is it something that can be studied using scientific techniques and methods? Is science itself independent of consciousness, or is science an activity of consciousness? And if so, can science study itself in that way? Is consciousness perhaps something more than just what motivates our cognitive activity, but something much more broad and much more profound than that? Is it possibly some kind of primordial organizing principle? Is it that which drives the creation of reality from the ground up? In any event, as I say, I've run out of time. I haven't been watching the clock, and I apologize if I've taken too long. But thank you, and I hope to speak to you, or many of you again tomorrow. And thank you for coming.
Program will be tomorrow. This is just a small sampling, so you can imagine what her presentation will be like tomorrow. I'm excited to introduce our final speaker of the evening. For the past 4 decades, Stuart Hameroff has been at the forefront of research into the nature of consciousness. In the 1990s, he teamed with renowned physicist Sir Roger Penrose to develop orchestrative objective reduction, a theory of consciousness based on microtubule quantum computing. In 1998, with a generous grant from the Fetzer Institute, Professor Hameroff co-founded the University of Arizona's Center for Consciousness Studies. He's author of more than 100 scientific articles and books on the subject of consciousness, and you may know him from any of his many appearances on television and in documentary films for the BBC, PBS, Discovery, the History Channel, and elsewhere. He is Emeritus Professor of Anesthesiology at the University of Arizona Medical Center, and we are thrilled that he agreed to be with us here this weekend. Would you please join me in welcoming Professor Stuart Hameroff.
Interlude while we set up his PowerPoint. This is a great time for a bachelor's. it working? I don't use this one. I hope you don't get feedback. That's not working? It is, okay. I have to really close. Can you hear me now? Oh yeah, you can hear me now. Okay. Thank you. Sorry for the delay. Thank you all for being here. It's a great crowd and a great group. I've been following the Krishna movement for many, many years, thanks to my good friend Kuladri, that I was a fraternity brother in college, believe it or not, many years ago, along with our other friend Jay, and we stayed in touch. And so it's a great honor and a privilege to be here. And he's one of the reasons I got interested in consciousness, actually, and also a philosophy of mind class. When I got to medical school, I was interested in the brain-mind problem and wound up in anesthesia, where we take away consciousness. And in fact, I've been passing gas for over 45 years, and I'm pretty well paid. Everybody passes gas, but I'm paid for it. So I'm also in psychology and director of the Center for Consciousness Studies. So what is consciousness? That's why we're here. We take it for granted that when we open our eyes, the world out there appears inside our head. Bing. And I'm going to use Bing to mean conscious experience, because the brain does a lot of things that are not conscious. We're doing automatic things, subconscious, non-conscious things all the time. And we sort of know how that works. We don't have a clue, really. Well, I think we do. But it's really a mystery still what consciousness actually is. And it's approaching science to neuroscientists who probe the brain with electrodes, artificial intelligence and roboticists, artists who try to capture the essence of reality and the world out there, physicists, Schrodinger's cat, the nature of reality, quantum physics, psychiatrists, anesthesiologists, oh, that looks sort of like me. Meditators, Eastern philosophers, and Western philosophers. So how does that happen? Well, let's start with Western philosophy and neuroscience, going back to Plato. He would have said something like, the world out there is all in our head. Bing. So the Bing is our head, the world out there is a representation. We don't really know what's out there. Plato realized that was a problem. Plato's cave was a story about how you could trick into thinking 2 dimensions was all there is. Descartes with his, for all we know, it could be brain of that, fed information by an evil genius. So the world as a representation leaves us with a mystery of what's really out there. We don't know. Now in Eastern philosophy, consciousness pervades a deeper level of reality. Being. Consciousness is everywhere. We're quite literally awash in a sea of consciousness, according to Eastern philosophy. Can we reconcile these two views? I think we can. Let's go back to the Western modern science type of view. And on the left, you see a bunch of neurons connected by synapses. And an analogy has been made to a computer, which has nodes, switches, and bits as bits of information. And so neuronal fires are thought to be like bits of information. And this is all based on something called the Hodgkin-Huxley integrate and fire neuron. In the 50s, Hodgkin-Huxley did some basic studies on what neurons do, integrate and fire. And this is one data slide. And basically, this is what is predicted by Hodgkin-Huxley, where integration occurs here in the dendrites and soma of the neuron, reaches a threshold, a fairly narrow threshold. And down here we see how narrow the threshold is, and then there's firing. So integrate and fire. At a critical threshold of each neuron of inputs, there's a firing. And that firing is taken by most neuroscientists to be the bits of information in the brain. And so this is applied to real neurons. So here we see a real neuron with dendrites and soma, and the information is transmitted solely along the surface of the membrane by ion channels opening and closing to the next layer of neurons. So the integration is in the cell body, the dendrites, and the firing is in the axon, integrate fire, integrate fire, integrate fire, and you put enough of these together, supposedly, and you get a computer. Now the problem with that is, if that is the case, and many people believe that it is, that what we get is algorithmic, deterministic, and machine-like. And basically, it's modeling, taking the brain and assuming it's a machine, and then therefore you get a machine. There's no room for consciousness, there's no room for creativity, intuition, insight, free will. And accordingly, consciousness is considered epiphenomenal in modern science and philosophy. And like Pac-Man, you guys remember Pac-Man a while ago, a long video game, where he's controlled by the joystick, everything he does. So in this case, our actions would be controlled by our automatic brain. And the fact that we have an illusion, that we have free will, is thought to be an illusion. That's the party line in modern neuroscience, because that's what following Hodgkin-Huxley tells us. And as the result is, as Thomas Huxley said, we are conscious automata, merely helpless spectators along for the ride. Free will is an illusion. And there's some other reasons to think this in modern science, because consciousness, the activity that correlates with consciousness comes too late, after we respond to something. So the idea is we respond non-consciously and have this illusion that we're acting consciously. I don't think that's true. And for example, there's actually some evidence of testing the Hodgkin-Huxley idea in neurons in awake animals. And what you see there is not a very narrow threshold and a very narrow time window, but a very broad one, and shown here in the data. And there's deviation from this, which means that there's something else going on. There's something other than just the membrane activities that lead to firing. Something non-computable that Roger Penrose calls it. Regulates firings or spikes. And whatever this is, it's a good candidate for consciousness, because it could be the Bing that's modulating the firing, so that what we do is not necessarily always automatic, always algorithmic, and always just totally based on inputs. It gives some wiggle room where consciousness can, hey, I feel like doing that, or I gut feeling I'm going to do that. And it puts us in the possibility of having free will. So where would this come from? Where would this consciousness come from if the neural membranes are kind of algorithmic and deterministic? Well, the obvious place for me is a deeper level. Now you might say, well, consciousness is from the universe and so forth, but to get there you have to go small. You have to go inside the neuron and into the quantum realm, which I'll get to in a second. So if you think about a neuron, there's membrane activities here, and then there's an inner world of a neuron called the cytoskeleton, the microtubules. And they're different from dendrites than they are in axons. But it seems to me that where consciousness is coming from is inside the neuron, modulating membrane activity, so that everything isn't strictly algorithmic and deterministic. There's wiggle room. There's consciousness can come in from inside the neurons and modulate what the neural membrane is doing, and that's how sometimes we act differently than we would automatically. We have a gut feeling. We follow intuition, insight, and so forth. And this is also very much like something that's come along in artificial intelligence called deep learning, where there's actually networks which could be inside of other networks that are modulating the activity of a network. Now, another reason to think that the neuron membrane isn't, and synapses and being part of a network isn't the whole deal, is a single-cell organism, or many single-cell organisms. You might have seen recently an amoeba solve the traveling salesman problem, which is thought to be an extremely difficult problem for computing. But there's also this single cell that I like called paramecium that swims around, it finds food, it avoids obstacles, it swims in a different direction. It can learn, it's like a little capillary tube, it escapes faster each time, it avoids predators, it finds food, it finds a mate, it has sex. And there's no synapse, there's just one cell. And here's kind of an X-rated image of two paramecium fused and coupled. And we don't necessarily know whether they're conscious or not, but it'd be a pretty good reason to promote procreation if sex felt good, which it does. So there could be feelings down at that level. Now, how does the paramecium do it? It doesn't have any inputs, it doesn't have any synapses telling it what to do. It does it by these little hair-like projections on the surface that are called cilia. And here's a picture of a paramecium with cilia coming out. And if you look at a cross-section of cilia, it's got these weird 9 pairs of structures called microtubules. And here's the cilia coming out of the paramecium. And if you look at it, it looks like this. Actually, this is triplets. 9 of each making a larger cylinder. And these stick out and move and act as oars and sensors for the paramecium to swim around. And how do they bend in an organized fashion? Well, if we do the cross-section of the cilium and look at one of these microtubules, we see these motor proteins called dynein that contract with ATP. So if this one contracts, and this one contracts, and this one contracts, it moves in an organized way. Or if it bumps into something, there's going to be a signal conveyed along the microtubule. Now, what does this have to do with consciousness? I'm not necessarily saying that's conscious. However, this mechanism, the dynein bending dynein on the microtubule, are the same structures that organize interiors of brain neurons and other cells. I showed you before a picture of a neuron, and here we see a neuron immunofluorescence micrograph, where yellow is the microtubule structures inside the neuron, blue is the nucleus, and red are active, and here's the membrane protein. So most of neuroscience just looks at what's happening at the membrane, and I think that's why we're missing consciousness. We need to go to a deeper level. And when we do, when we look at, for example, here's a neuron, and down its dendrite, let's say there's a synapse here or somewhere. So material that is needed to regulate the synapse is manufactured in the cell body. It needs to be transported out to here quickly to give more dopamine decarboxylase, whatever, to fit the synapse. And how that happens is that these dynein, the same dynein motor protein in the paramecium cilium, and another one called kinesin, carry stuff along the microtubule. If you see a video of this, literally they run along. It's quite amazing, actually. But how do they know where to get off? How do they know which synapse needs more enzymes? And that turns out to be coded on the microtubule by tau protein. Tau is a microtubule-associated protein, and when it falls off and when that causes the microtubules to disassemble, you get clumps of tau. That's called neurofibrillary tangles, and you get Alzheimer's disease. So Alzheimer's disease is famous for the amyloid plaques that are on the outside of the neurons, but what actually causes the disease and the loss of memory is the loss of tau encoding on microtubules and disintegration of the microtubules. And actually, we have a strategy, I'll tell you later, about how to treat Alzheimer's by resonating microtubules and putting them back together. So, how do the tau know exactly where to go on the microtubule? It's kind of like a FedEx code. It's kind of like some postal code that tells the motor proteins where to go, where to get off. Is there information processing in the microtubule? And this is something that I got interested in when I first learned about microtubules back in medical school. I was working in a cancer lab, studying mitosis and looking how chromosomes were divided by these structures, which were microtubules. At the same time, it was discovered that neurons were full of microtubules, and that their structure was discovered. And it turned out to be this cylindrical lattice of individual peanut-shaped proteins called tubulin. And I got the idea back in the 70s that these things might be acting like computers, and each tubulin could be, let's say, open or closed, a 1 or a 0. And I was reading about the game of life, which is a cellular automata, and we did some modeling of microtubules as a cellular automata. Cell should mean the smallest unit, but in this case, we're inside the cell. So we call them microtubule automata. And we showed you can get information processing and patterns moving through the microtubules. So in the 70s and then the 80s, I began publishing on the idea of microtubule computing with some colleagues, Rich Watt, and I wrote a book about it in 1987 about it, and then Steen Rasmussen, a physicist at Los Alamos, where we did the molecular automata, and then some other work. And then in the 90s, I met Roger Penrose, and we started talking about quantum computing in microtubules, and I'll get to that in a second. So if that's the case, if microtubules are processing information inside neurons, that means there's a huge amount of information processing in each neuron. So the AI people, the people who say, give us another couple billion and we'll have a computer that can be conscious because it's just a matter of more switches, more bits, more computation, they set their goalpost to reach brain equivalence is based on this. Also the singularity, Ray Kurzweil's idea. 10 to the 11th neurons per brain, 1,000 synapses per neuron, at about 100 hertz, gives you 10 to the 16th operations per second per brain. 10 to the 16th, that's a lot. However, if you add the microtubules, information processing inside, you get 10 to the 11th neurons per brain, 10 to the 9th tubulins per neuron, switching at about 10 million times a second. This gives you 10 to the 16th operations per second per neuron, 10 to the 27th operations per second for the whole brain. So 11 orders of magnitude more than what the AI people are telling us will be necessary. So I was going around to AI and neural net meetings in the late 80s being a pain in their butt because I was saying, oh no, you guys are wrong, you need another 11 orders of magnitude. And I was a pest, and they didn't like that. But one day somebody said to me, he says, well, okay, wise guy, let's say you're right. Let's say the microtubules are doing all this stuff. How does that explain consciousness? How does that explain feelings, joy, love, pinkness, anything, any experience whatsoever? And I had to admit, I was stumped. I didn't know. This later became known as the heart problem. It was coined by David Chalmers. It had been bandied about by many others earlier. But I was struck by it, and I took a long look at myself in the mirror and realized I was a reductionist and really didn't have a clue what was causing consciousness. Fortunately, that same person suggested to me that I read a book by Roger Penrose called The Emperor's New Mind. That person, I can't remember who he was, but I'm indebted to him. Basically saying, where's consciousness, where's the being, is something else required, and is it quantum physics? So he suggested this book, which I read, and was really blown away by it. This came out in 1989, The Emperor's New Mind. And the title is meant to, like, the emperor has no clothes. And Roger Penrose was basically saying, AI, you don't have a clue. You don't have a mind in your computer because consciousness is not a computation. And everybody has assumed since day one that the brain is a computer and consciousness is an output. Well, if you have an output from a computer, who's looking at it? Somebody has to look at it, right? So who's looking at the output? Well, you are, but who are you? Well, you're consciousness. So it's kind of you go in a circle. But Roger did a very elaborate and very detailed philosophical approach using something called Gödel's theorem to show that conscious understanding is non-computational, that something outside the computational system is required. A simpler way to put this may be that if you know something, I know that that equation's right, or I know that I love my wife, or I know this or that. Knowing is a feeling, right? You can't prove it by some equation, you just know it. And that's even true for mathematical equations. That was Roger's approach. Anyway, in the book he also said that something is most likely to be involved with quantum state reduction, with collapse of the wave function, and the measurement problem in quantum mechanics. And we'll get to that in a second. And that factor relating quantum mechanics and measurement related to the underlying structure of the universe, namely space-time geometry or quantum gravity, and which relate to general relativity. Now, quantum mechanics and general relativity are two cornerstones of modern science, but they don't interact. They've never actually interacted. Quantum mechanics describes small stuff, general relativity, large stuff, and nobody ever put them together until Roger. And that this would introduce, and how this happened was a bit hard to understand at that time, and still a bit. This would introduce a non-computable influence, something outside the system, that you could know something or have some non-algorithmic processing. So I read the book, I was blown away by it. I didn't understand a lot of it, but I knew a couple things. This guy was brilliant. He had some really crazy and interesting ideas, and nobody else had ever proposed a mechanism for consciousness. It was the first, and I think the only specific mechanism, other than kind of hand-waving emergence and complexity and blah, 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 which there's really no actual basis for. But I didn't have a clue about quantum mechanics, and I tried to learn. I got into it. And so I'm going to give you my simple version of quantum mechanics, because it is very difficult. The world is divided into two realms, it seems. The quantum realm and the classical realm. The classical realm is fairly large, Newton's laws, Maxwell's equations. You throw a ball, gravity pulls it down, etc., etc. It's predictable, classical. It works. At small scales, however, things get very, very weird. At small scales, we have quantum superposition, which means that things can be in multiple states or locations at the same time. Something can be here and here at the same time. There's non-locality, as Brenda mentioned, where you have connection of things over distance due to entanglement. Quantum particles are separated, you make a measurement here, this one over here feels it immediately and changes. Immediately. Einstein didn't like that because it meant faster than light, which he had said speed of light was an absolute. So he called it spooky action at a distance and didn't like it at all and was against it. He designed a thought experiment, Einstein, Podolsky, Rosen, which would disprove it. When they eventually did the experiment, it actually proved non-locality. And he admitted he was wrong on that. He was right up just about everything else. But, and things are wave-like and small in the quantum world. They're connected over distance, they can be in multiple states or locations, and they're wave-like. But we don't see quantum superpositions. We don't see quantum stuff in our classical world. I see one of you, presumably you see one of me. Things aren't smeared around like a wave. They're in definite places. Now, for example, a particle can exist as a wave of multiple possibilities. Here's an atom. I think it's a cesium atom. Here in the yellow, it's in one location, but in the background, you see it in its waveform, where it's actually in multiple locations at the same time. This is quantum superposition. So it can be a wave or a particle. It can be in multiple locations, but when you but when you observe it or measure it, it's in one location. The world we consciously perceive is exclusively made of particles in definite states, not waves of superposition. And in the early days of quantum mechanics, at the turn of the 20th century, Niels Bohr and all those guys found that experiments seemed to show that superposition persisted only until being measured or consciously observed. It's like the refrigerator light. You close the door, you assume it goes off. You don't really know. Okay? So if you're not looking at something, it's a wave. It's in multiple locations. You look at it, and it collapses to one of the other. So the presumption was that consciousness collapses the wave function to definite states. So when you make a measurement or a conscious observation, and Wigner took it further. He said a machine can make a measurement, but until a human or conscious entity looks at the results in the machine, it's still in superposition. That's a tricky business, but that was the idea. Conscious observation causes collapse. And this is also known as the conscious observer effect, or the Copenhagen interpretation, after the Danish origin of Niels Bohr, its first proponent, its major proponent. And he was happy to avoid the problem so we could go on and make measurements. Shut up and calculate was his famous idea. And that led to great advances in quantum physics and all the technology we have today. TV, video monitors, electronics, it's all based on quantum mechanics. And so they got a jump start on that without Einstein was quite pleased. Here he is talking to Edison, Eddington. They both won Nobel Prizes, so they're having a good time. Good for them. Now, this is large scale. Roger Penrose comes along and says, well, wait a second. What about matter and space-time curvature at small scales, like getting into the quantum? Why can't we extend this to the quantum realm? And so he invented these two-dimensional space-time sheets. Those curvatures before were kind of hard to figure out. And so forth. He said, okay, let's take the 3 dimensions of space and make them 1 dimension of space. And time is there. So you have a 2-dimensional space-time sheet. So a particle here, it's going to be a tiny particle, is a curvature over here. And if it moves, or moves that way, it's a curvature over here. So the idea is that a particle oscillating between 2 positions could be space-time curvature moving back and forth. And then the next step was, well, superposition then is merely both curvatures. And you have a separation in fundamental space-time geometry. So this was the basic idea, and it also forms a quantum bit or a qubit, where you have a possibility here, and both possibilities. Now you might imagine if these continued, if these separations were to continue, you get multiple worlds. Each one would have its own universe. And that could be. But Roger proposed that these separations were unstable and will self-collapse, undergo objective reduction at a time t given by h over e sub g. H is Planck's constant, e sub g is the energy, gravitational self-energy of pulling something apart, which can be calculated from its mass and so forth. And at that time t, shown here, there would be a moment of conscious experience. So Roger had basically turned the Copenhagen interpretation around, the idea that consciousness causes collapse, and basically saying instead, collapse by objective reduction causes consciousness. So when this threshold is met, bing, there's a moment of conscious experience. And that produces consciousness. You don't have to bring in some mysterious entity from the, it's mysterious enough, but you don't have to bring in something else outside to cause it that you're excluding from your definition. When space-time curvature reaches this threshold, it collapses to one or the other. That's the perception you have, that's the choice you make, and that gives you a moment of conscious experience. Bing. So to distinguish that from the Copenhagen interpretation of consciousness causes collapse, where the conscious observer causes this one to cease and this one to continue, we have instead that you don't need the conscious observer, and the separation goes on, and at time t, bing, there's a moment of conscious experience. Now, these would be occurring randomly, kind of what we call decoherence, or people call decoherence, everywhere all the time. In the air, in the podium, in other parts of our body, of the brain, in everything. And they would be proto-conscious. So there's this proto-consciousness that are kind of random and lacking in meaning and so forth. And this seems weird, but it's not as weird as panpsychism, which a lot of neuroscientists resort to explain consciousness, because you can't explain it from computation. So they would be proto-conscious, and also like Whitehead's simple occasions of experience. Alfred North Whitehead was a philosopher who said everything was a process, and that there were occasions of experience occurring in a wider field of proto-conscious experience. So along those lines. But the proto-conscious moments, I kind of metaphorically liken them to, if you go to the symphony and each musician is tuning his or her instrument at the beginning, and you hear these random notes, it's kind of a noise, it's a cacophony. So that's what's happening all around with these random proto-conscious moments. What we need is for the orchestra to put it all together in a meaningful way. So the question then is, how could these proto-conscious random notes and sounds and noises be organized, orchestrated in the brain for full, rich, conscious experience? So, having read Roger's book, I realized that what he needed was a quantum computer in the brain which could biologically orchestrate quantum information processing, halt or terminate by Penrose objective reduction, connecting to space-time geometry, non-computable Platonic values, because he said when the collapse occurs, it's not random, but it's influenced by Platonic values embedded in the fine-scale structure of the universe, which has a lot of capacity for information, and also regulate neuronal and synaptic activities so that it could have influence in the brain. Well, I read this book, and having spent 20 years at that time studying microtubules, it was obvious to me, or at least I thought, hey, maybe it's microtubules. So I wrote to Roger and told him about the idea, and he liked the idea. We met in Oxford, and we became colleagues and friends and collaborators, and I invited him to the first Science of Consciousness conference in 1994 in Tucson, after which we went to the Grand Canyon. There's Roger, there's his wife Vanessa, that's me, about to fall in maybe. That's philosopher David Chalmers. So that whole trip was quite a trip, actually, because Dave and Roger were arguing in the car the whole way about this and that, and Brian Josephson was there, and there were a bunch of other people. So, but in a hike across the Kaibab Plateau, we began to develop our theory. I think Roger might have been slightly delirious from lack of water, but it got us started. We eventually developed it. So here we are many years later, after he gave an amazing talk at one of our conferences, and he's being mobbed, and I'm kind of acting like Secret Service to protect him. The basic idea was that we wanted a quantum bit in a microtubule. So here's a microtubule. We have these tubulin proteins. So initially we thought, oh, they change shape, and it's a 1 or a 0 due to quantum events inside. Turns out the shape change was a problem because it requires energy and it generates heat. So we subsequently changed to a dipole oscillation wrapped around the whole microtubule. So 2 possibilities and a superposition of both. And to kind of make a long story short, it developed into a hierarchical theory of consciousness. So here's a pyramidal neuron, and if we went further to the left, we see neural networks in the whole brain. But if we look inside, as we're going down in scale, we see 1 microtubule, then we see these tubulins with dipoles, and they're going back and forth, and this is where anesthesia works. And I'll talk briefly about anesthesia in a minute, because this is exactly where anesthesia works. And if we went further to the right, we get down to space-time geometry. So you can imagine that these information possibilities, yellow or blue, might extend right into space-time geometry. And these would occur at different frequencies, very slow EEG ranges, going faster and faster as you go smaller and smaller, and even further faster and smaller into the structure of the universe, space-time geometry. Now there is actually evidence for this from the work of Anirban Bandyopadhyay, who studied microtubule at 3 levels, the neurons, 1 microtubule here with 8 nanoprobes, and then just the tubulins, and found electrical conductances at certain alternating frequencies that give you this type of picture. And so, and these are kind of self-similar triplets of triplets, he called them. So Anirban is a good colleague of ours. He's in Japan, working at the National Institute of Material Sciences. He's still very active in this field. Now, let me talk a little bit about anesthesia, because everybody thought anesthesia acts at membranes, lipids or membrane proteins, but it turns out that they act on microtubules. And the work of at Penn, Rod Eckenhoff's lab at Penn has shown in the last 10 years that anesthesia seems to act on microtubules. Now, what they do to microtubules is the question. So in this paper, my colleague Travis Craddock and others did a computer model. If you take 1 tubulin and look at it, it has 86 of these aromatic amino acids, tryptophan, phenylalanine, and tyrosine. And by the way, all psychoactive molecules, dopamine, serotonin, all the psychedelics are highly, they have these pi resonance group, these extra electrons, electron clouds. And we simulated quantum dipole couplings among all 86 of these pi resonance clouds. And this was a supercomputer. I had nothing to do with it. I had the original idea, but the other guys did the supercomputing modeling. And basically, we found it at ambient temperature. Everybody says, oh, the brain's too warm, wet, and noisy for quantum effects. Not true. At ambient room temperature, or biological temperature, we found a spectrum of dipole oscillations with a common mode peak at 613 terahertz in the blue light region of the spectrum. And these are the anesthetics. We then added various anesthetics and non-anesthetics, and we found that the anesthetic gases abolished and non-anesthetic gases, which found in the same place, did not abolish at 613 terahertz peak, which is in the blue light region of the spectrum. Now, blue light deep in the brain correlates with consciousness, and usually stays internal to the system. It's not emitted. However, as we all know, Hindu deities are often portrayed as blue. And I asked Kaladri why that was so, and he kind of punted a little bit. But it could be that consciousness is actually coming from blue light in the microtubules, which is normally internal, but in certain circumstances can get out. Now, getting back to the Orco-R theory, the idea was that we got to build up a quantum superposition, shown here in one microtubule, but there would be literally billions throughout the brain by entanglement, and relating to space-time geometry, and we've reached this threshold for consciousness being. And because we have billions of these, we can have very complex, so rather than just the proto-conscious moments that are random, these are quite literally orchestrated and organized so that we get full, rich conscious experience. You can also think about a slightly different metaphor as the proto-conscious moments are like if you have a palette and they're individual colors, and you take a dab of this, a dab of that, and you put it together into a masterpiece. Or you can think of it as the sounds and noise of the orchestra warming up, and then the band begins to play Brahms or Mozart or Beethoven or the Rolling Stones or whatever. And that's the difference between consciousness and proto-conscious moments. Orchestrate music versus noise. And actually, I have to say that I think after studying this for 40 years, that consciousness is more like music than it is like computation. I think the computer metaphor is severely lacking and is somewhat useful, but I don't think it's the answer. Another way to look at this is that we have a sequence of events, of conscious moments, that can occur at specific frequencies. And it appears continuous, much like if you watch a movie or a video that, which is made of individual frames, it appears continuous, except there you need an observer. So I think we're having these sequences of discrete moments of conscious experience at various frequencies. And what the frequencies are is an interesting question. We initially thought they were like at 40 hertz, like gamma synchrony EEG. But now we think they're happening at like 10 million times a second, and we get interference beats among them that give us slower activity like EEG. And so again, it's a multi-scale hierarchy with resonance and interference across many, many scales. Another approach to the heart problem, which is why we have experience, would be that why do we see red, or why do we have the experience of red? The classical approach would be that in her brain, there's a particular pattern of activity that gives bing, okay, as shown in an MRI or something. In our view, it's a particular pattern in space-time geometry, not just 3 of these curves, but many, many more, that's intrinsic to the rows, and that is repeated in our brain. We recreate that same space-time geometry, perhaps by entanglement, in our brain, and that's how and why we have experience. So we can attempt to solve the so-called heart problem that way. Another feature of Roger's ideas were that the choices selected in each collapse, rather than being random as they are in other quantum approaches, are actually influenced by Platonic values embedded in space-time geometry. Now, he initially was referring to mathematical truths, that mathematics is somehow embedded in the structure of reality. But in some of our papers, we extended it to aesthetic values and ethical values. Goodness, beauty, whatnot are actually, we perceive them because our brains, our microtubules resonate with those Platonic values that are embedded in the structure of space-time geometry, and they can thus influence our activities. For example, well, here's one way. This is a cartoon I did for a paper where this guy is a robot, non-conscious, sailing towards A or B, but non-computable influence, which make him then conscious, or is conscious, would make him sail towards C. So this is something changing the algorithmic approach. These non-computable, in this case it's the wind, but it's a metaphor for the non-computable influences in space-time geometry. So let's go back to our hierarchy here. And we extended it to the right into space-time geometry. And what if we go, and that's already pretty small, and can be independent of biology. So it could go into the structure of space-time geometry, which is also hierarchical. And I have to admit that I stole this slide from Joshua's brother, Brian Greene, advocating for string theory, but I think it serves, regardless of strings, something else. So as you go down and down and down in scale, eventually you get to the basement level of the universe, the Planck scale, where there's information. So it might appear smooth and continuous, but eventually you get to the Planck scale and you have information. Well, if that's the case, consciousness could also extend down that way, and we could be getting Bing as we go down into the structure of space-time geometry, and which could be independent of biology. And about, let's see, when was it? 20 years ago, the BBC did a show about near-death and out-of-body experiences after these studies were done in Europe. And they had asked the people who did this study, Pim Lummel and Peter Fenwick, well, how do you explain people floating above their bodies or claiming to float above their bodies? And they said, we don't know. Why don't you ask Penrose and Hameroff, because they have this crazy idea that consciousness is in space-time geometry. Well, Roger had the good wisdom not to answer. But I said, well, what the heck? It could be that when the blood stops flowing and the oxygen stops being delivered, the quantum information in the microtubules kind of dissipates to since it's happening in space-time geometry to begin with, it dissipates to the universe at large, but remains entangled, so that you can have, quite literally, consciousness or a soul free of the body, at least temporarily. And then if the patient's resuscitated, it goes back in. If not, maybe it can stay independent, or maybe it can go into another embryo or zygote or a set of microtubules or whatever. But in any case, it can in principle account for consciousness out of the body. I don't think that's impossible. And I know I get a lot of criticism from mainstream scientists for saying this, but what I say back to them is, well, until you can explain consciousness in the brain, you cannot disprove it out of the brain. And if it's a quantum effect in the brain, it can be a quantum effect out of the brain. And I'll stand by that. There's actually some evidence in medicine from so-called end-of-life brain activity from patients from whom, for whatever reason, support is withdrawn, they're on ventilator, they're on drugs, and so forth. And a guy named Lakhmir Chawla at George Washington University started putting these simple EEG machines on patients as they died. And what happened was, and they had this number, 0 to 100, and 80 to 100, you're conscious. 40 to 60 is where you want your anesthetized patients. If you're down here, you have severe brain damage. And what they found was that at the time of death, as this dwindled to 0, they got this burst of activity that could last 90 seconds to many minutes of what looked like gamma synchrony EEG, which is the best marker of consciousness that there is. And this continues to confound people, and people don't want to do it anymore. In fact, they started doing it in the ICU, and they found that about half the patients had it, but the families of those who didn't have it were depressed because maybe their loved one didn't go to heaven or whatever. I don't know, but it does happen at least 50% of the time in the ICU, or when patients die. Now, let's get back to space-time geometry. What is it that's actually curving? Well, we don't really know the answer to that. Roger is probably the world's expert on that. And but this is an old story. He developed spin networks, twisters, quantum gravity, quantum geometry, and so forth. So all these things describe what the nothingness is made of. Because if you go down in scale, below atoms, and eventually get to the Planck scale, it's nothingness. But there's information there. There's some kind of information, something. And it's one of these things, or maybe something else. But the point is that there is some information there. Now, just a couple things about scale. If we go, here's like the whole universe. This is like the size of the universe, and here's the Planck scale. And on a log scale, consciousness and biology is in the middle, more or less. So that multi-scale hierarchy I showed from the would go about here, which is interesting because it kind of gives opportunities for leverage, and it's interesting that we're kind of in the middle between the tiniest and the largest. And if we go back to this hierarchical idea of space-time geometry, it reminded me of stuff that Kuladri was talking about when we were in college, and afterwards about Krishna consciousness. And I found this somewhat hierarchical image of Krishna consciousness that has, as you can see, the cosmos in it. But in the background, you see this hierarchy. And I think that that's the key point. And I think reality, the universe is a hierarchical system. Consciousness can occur at various levels of it, go up and down. So let's ask another question. When did consciousness arise? So here's a brief history of the universe, Big Bang. Here we are, well, a few years ago. So we can ask the question, when did consciousness arise? And a lot of people would say fairly recently with tools and language. Others would say the origin of animal cells with eukaryotes. Others when life began. And others before the Big Bang and before the universe. Actually, both Eastern philosophers and Western philosophers say this. Colin McGinn, for example, Eastern philosophers would say that. And so, but let's just hone in on one question. Which came first, consciousness or life? And Western science and philosophy would say that life preceded consciousness, which emerged from biological information processing. The brain's a computer, you get complicated enough information processing, consciousness happens. However, Eastern philosophy, panpsychism, quantum approaches such as ours, consciousness preceded life and has been here all along. So what is life? It's really another mystery. All this metabolism and stuff, it doesn't really explain what it is. Life on Earth apparently began in a primordial soup proposed in the 20s by Oppert and Haldane, a simmering mix, or a hot spring, as proposed by Bruce Dahmer, from which biomolecules emerged 4 to billions of years ago. And in the 1950s, Miller and Urey simulated this and found organic amphipathic biomolecules. So this means a nonpolar pi resonance kind of quantum molecule end of it, and then a polar tail. This is very much like dopamine. Dopamine is the pleasure molecule. And these are found in the primordial soup. So I wrote a paper about this, imagining how if these feelings, that maybe there were feelings in the primordial soup. So imagine that these molecules organized and they reached this threshold for OR. Maybe you need many, many more of these. And they begin to have conscious moments and correlating with the same thing happening in space-time geometry. And they form what Oppert called micelles. So the question is, did primitive pleasure spark the origin of life? And you get a bing, and if you're a little molecule swimming around and something feels good, you want to do it again, right? You want to optimize it. And so I think now these primitive events would be random, proto-conscious, but some would be positive and feel good. So there's a bing with a little smiley face. And this could have provided feedback fitness function for living systems to evolve. And so that life evolved and organized to optimize pleasure and avoid displeasure. If these feelings were available by these molecules getting together, these dopamine-like molecules, maybe that's what prompted the origin of life. And I wrote a chapter about this, the quantum origin of life, how the brain evolved to feel good. And it was somewhat of an attack on evolution, but not necessarily Darwin. Darwin is a pillar of science, but the notion that life evolved behavior to promote gene survival, such as Richard Dawkins says, is an assumption which doesn't make sense. Why would an organism give a crap about promoting its genes if it doesn't involve feelings? Why would it care or do anything, really? It just didn't make sense to me. Behavior is driven by reward, pleasure avoiding pain. Every animal experiment, every rat in a maze, every experiment in a biolab, the animals are seeking reward, seeking pleasure. Pleasure, in our sense, can include hedonism, pleasure, but also altruism. Giving is better than receiving, spiritual pleasure, and so forth. There were no genes in the primordial soup, so without something like this, how do we get from primordial soup to genes billions of years later? And most importantly, evolutionary theory ignores consciousness and feelings. So I raised the question in that paper, did feelings drive evolution? And I'm still waiting for people to refute it or say why it's wrong. Nobody's jumped on the bandwagon yet that I know of, but I still like the idea. And I call it the quantum pleasure principle after Freud's beyond the pleasure principle. Now, to wrap up, let me just say one more thing. Roger wrote another book a few years ago called The Cycles of Time, in which he said that the Big Bang was not the beginning. And that instead of the Big Bang, so here's a Big Bang, and the universe is expanded, runs out of heat or whatever, but then rather than that being the end, there's another one. And that was preceded by another one. And then through something called conformal rescaling, it looks more like this. A continuous eternal universe rather than having a beginning and an end, and with these crossover points. And they've actually found evidence for this by looking in the cosmic microwave background, seeing concentric rings that appear to come from big black hole collisions in the previous eon. So it's not a previous universe, it's one universe with multiple eons, and we see evidence from the previous eon. Well, if that's the case, was there consciousness in the previous eon? Well, who knows, but why not? I mean, if the conditions were there. And that raises something, this will be my last point, called the finely tuned universe problem, or the anthropic principle. And this is the concept that values of fundamental physical constants, all these numbers, and I'll show you that there's about 20 of them, that the mass of the proton and the charge of this and this ratio and that ratio. And people have shown that if these 20 numbers weren't exactly what they are, if any of them deviated even slightly, we wouldn't have a universe habitable by life or consciousness. We wouldn't have stars, we wouldn't have life, we wouldn't have consciousness. So the universe is perfectly tuned for consciousness, for life and consciousness. Now the anthropic principle encompasses explanations for the finely tuned universe. Now here's the dimensionless constants, various numbers that we don't really have to concern ourselves with. And there's two major approaches to the anthropic principle. The weak anthropic principle by Brandon Carter suggests, it depends on the multiple world hypothesis. Remember that, there's an infinite number of worlds. Suggests we won the cosmic lottery. We exist in the one and only universe of an infinite number of parallel universes able to support consciousness. It's a selection biases. We are the only ones, or those of us living in this universe, all of us, we are the only ones able to ask the question. There's a whole bunch of other universes out there where there's nobody conscious enough to ask the question. So it relies on the multiple universe idea, and there's one universe, and there we are, smiley face, being conscious. I don't think that's right. There's another idea that was put forth by Barrow and Tipler, the strong anthropic principle, which is more religious, which suggests that life and consciousness play some intrinsic role in the nature of the universe by influencing those constants, which are somehow embedded in space-time geometry. How could that happen? Well, one way would be God. God comes along and sets all the physical constants. Or, if you go to Roger's idea, could fundamental constants mutate and evolve with each eon transition? With every crossover from one eon to another, it's kind of like evolution and mutation and evolution. And the constants evolve to optimize consciousness in the next eon. So consciousness would be optimizing these constants for itself to promote consciousness. And therefore consciousness is not only driving evolution of life, but also evolution of the universe. So let me close with some conclusions. And basically what I want to say is that consciousness consists of self-organized rearrangements, or ripples, you might say, in the fine-scale structure of the universe. So if you go back to that slide where Bing is everywhere, that's kind of what it is, except instead of being just kind of painted on, it's actually a process. It's like little ripples and self-organizing ripples, and that's going on in all of our minds, microtubules right now. These ripples, each a wave function collapse due to Penrose's objective reduction, are orchestrated, OR, that's the theory he and I developed, and connected to the brain by quantum vibrations in microtubules, and connected to platonic values embedded in space-time geometry. And that consciousness may be guiding evolution of life and the eternal universe itself. Thank you. Sure.
We have time for just a couple of questions from the audience, if you'd like. Just raise your hand. Yes.
Thank you so much. So earlier when you were talking about the quantum mechanics, there's the superposition, and you connected that to, I was wondering if you could also reiterate how the credibility behind superposition, and then with that, how, if that's relating to consciousness, you had the wave with like two little things, I guess, and then they separate. And that would be like an indication, or one theory was saying that that was an indication of consciousness. So does that follow with the slides you were showing, how you saw potentially consciousness could survive, at least for some portion of time, separate from a body? But then where would the energy be coming from for those two, I guess, things to continue separating to create that consciousness experience if it's leaving the body? So where's like the movement, the mechanics for that energy?
Okay, you've asked several questions. So one thing was, I was trying to distinguish between consciousness as an outside entity causing collapse of the wave function. Instead, the superpositions are proposed to be separations in space-time geometry, curvature, and these separate, and that separation in the fabric of reality is unstable, and after a time t will collapse to one or the other. And when that happens, that gives a moment of consciousness. Now, the other part of your question was, where does the energy come from when consciousness leaves the body? And there's plenty of energy in the universe at large. There's zero-point energy, there's all kinds of energy. So that's not a problem. And I mean, if you want it, you could ask that of the multiple worlds. There seems to be a conservation of energy problem. So, but there's plenty of energy in the universe itself, even though it's cold at the smallest scales. So I don't think that's a problem. And these, you don't need a whole lot. We need energy for our physical bodies, but consciousness itself is probably a very low energy process. And I always remember that in medicine, because the patients who are critically injured may look really bad, but their consciousness may still be there. And we're always surprised at how consciousness can survive even horrible things, because it's low energy. It can survive low energy situations.
In the interest of time, we're just going to take one or two other questions. I've been informed that the Stuart's books are available in the bookstore. The bookstore closes promptly at 9. However, there will be books available as well tomorrow. Did I see a hand here?
Right here. Thank you very much. Listening to you, I have the impression that by consciousness you mean a single entity, or a single state, or a single rearrangement. But we know that there are several different conscious states. We've got feelings, emotions, visual experience, and so on and so forth. So there's a big, huge diversity of mental states, of conscious states. So my question is that how to account for that? And if you...
Yeah, sure. They're all examples of consciousness. And as far as the brain, when things are processed in the visual system from visual inputs, you get visual experience. But and auditory, the same thing. And emotions, maybe the limbic system, and so forth. So it depends where in the brain. But in the end, I think they're all pretty much the same. And also, our brains also, or our minds, or our consciousness, unifies all these disparate types of experience by binding. The binding problem in neuroscience. So, for example, if you see a visual object, you see something moving through the sky. Its shape, color, motion, and meaning are processed in different parts of visual cortex. Shape, color, motion, meaning moving forward. And you don't see something red, you don't see a triangle, you see a red kite, or you see an airplane, or you see a bird. And what's interesting is that not only are these processed in different areas, they're processed at different times. And yet you see at one instant a red kite, or a blue bird, or an airplane, or whatever. So that tells me that these things are bound together by quantum entanglement. And there's actually some evidence for that. And that extends everything. How do you, then you have to integrate and bring in auditory, feelings and so forth. I mean, our one conscious moment can have all of these things bound together. So, but you're asking how are they different, and they're processed different parts of the brain, but then I think they're all bound together through quantum entanglement. So we have a unified conscious experience of whatever it is.
Would you please join me in thanking Professor Hameroff for being here? Tomorrow. Please show up early. We're going to hit the ground running. Management has asked me to offer one caveat here. If, as a result of your attendance here at this program, you achieve full self-realization as pure consciousness and become renowned as an enlightened being, the program organizers reserve the right to collect a 10% royalty on sales of your biography and any film or television adaptations of your life story. Get a good night's sleep. We'll see you in the morning. Thank you.